Bismillahirrahmanirrahim. We are discussing this topic, which is integration by part. In the last example we gave, or in the last part we gave different type of examples how to find or how to apply the integration by part. We are continuing this topic now by giving more examples. But before doing that, in some cases we have to repeat the integration by part more than one time. And if we need the integration by part more than one time, we are applying something called the tabular method. So for today, we are going to speak about the tabular method. For the tabular method, we are choosing U and dv. As we mentioned before, in the first one, we differentiate, and the second one, we integrate. So for the tabular method means it is just repeated integration by part. So the first one I will differentiate and then I will integrate the second one. But sometimes I need more than one time to integrate or to find the integration by part. So I'm going to differentiate for the second time and integrate the second one. Differentiate for the third time and find another integration. And keep doing like this. So we can say that in the tabular method, integration of u dv can be written as uv minus integration of v du plus u double dash integration of v. It's just moving diagonally. V bar or prime, u double dash like this. Start with the sign plus minus plus minus. Now to explain this idea. Usually this is used to find the integration by part in general if we have polynomial multiplied by another function or exponential and trigonometric. So that then we will get the original function after certain steps. For example, let's evaluate. Number one, x squared cosine x dx. So I will choose u to be x squared and dv will be cosine x. Now differentiate the first one and integrate the second one. So the derivative for the first one will give me 2x. Integration of cosine will be sine x. Differentiate again, 2. Integrate, sine x will give me minus cosine x. Differentiate, one more, I will get 0. And integrate minus cosine will give me minus sine x. Now, multiply the first one with the second one in the second column, second with the third with the fourth. And keep in mind that start with positive plus minus plus. But I got 0 there, so no need to use this part. So the integration of x squared cosine x dx will be, start with positive, it is plus x squared multiplied by sine x. Second one is minus. So let me just use the green. Minus 2x multiplied by minus cosine x. Third one is a plus. So plus 2 multiplied by minus sine x plus constant c because this is indefinite. So I can write it again as it is x squared multiplied by sine x minus with minus will give me plus 2x cosine x minus 2 sine x plus constant c, and that's it. So this is integration using the tabular method. Again, tabular method is just repeating integration by part 1 or 2 or 3 times. Let's take another one. Number 2. I want to evaluate the integration of 2x squared minus 3x plus 1 multiplied by e to power 2x minus 1 dx, exponential and polynomial. Usually, let u equal to the polynomial. Because if we use the polynomial, it will be easier to stop, because if we differentiate the polynomial many times, I will get 0 at the end. So we can stop at that point. Now I will choose the first function. It is 2x squared minus 3x plus 1 and e to power 2x minus 1. So I will differentiate this one and integrate. Differentiate and integrate. So the derivative will be 4x minus 3. The integral of e to power 2x minus 1 will be 1 over 2 e to power 2x minus 1. You can do this by integration by substitution. Now differentiate for the second one. I will get 4. And that one will give me, if we integrate, I will have 1 over 4 e to power 2x minus 1. Again, I use integration by substitution to find the integration of e to power 2x minus 1. Third one, I will get 0 and 1 over 8 e to power 2x minus 1. Now I will multiply first for the first column with the second in the second column, second with the third, third with the fourth one. And keep in mind, start with positive, negative, and positive. So the integration now will be the integration of 2x squared minus 3x plus 1 multiplied by cosine, not cosine, this time it is e to power 2x minus 1 dx is equal to plus 2x squared minus 3x plus 1 multiplied by 1 half e to power 2x minus 1. This is the first one. Second one is minus, and the derivative is 4x minus 3 multiplied by 1 over 4 e to power 2x minus 1. Third one will be plus 4 multiplied by 1 over 8 e to power 2x minus 1 plus constant c, because this is indefinite. So just to make it more organized now, I'm going to write it again. I will have 1 over 2 e to power 2x squared minus 3x plus 1 e to power 2x minus 1. Second one will be minus 1 over 4 multiplied by 4x minus 3 e to power 2x minus 1. Third one, cancel 4 with 8. I will have 1 over 2 e to power 2x minus 1 plus the constant c. So this is the application for the tabular method. Take one more. Number 3. is the integrate. X squared minus 5x plus 1 multiplied by cosine 3x dx. Each time if you have polynomial multiplied by another function, try to apply the tabular method. Repeated integration by part. So I'm going to choose this one to be u, will be the polynomial will be the one that I'm going to differentiate. 5x plus 1, and I have cosine 3x. Differentiate the first one and integrate the second one. So it is 2x minus 5, and the integration for the cosine will be 1/3 sine 3x. Differentiate again, I will have 2. Then the integration of 1/3 sine will give me minus 1/3 cosine. One more, 0 and minus 1 over, so this is 1 over 9, 1 over 27 sine 3x. As we did, start with positive, negative, and positive. So the integration now is equal to, it is plus x squared minus 5x plus 1 multiplied by 1/3 sine 3x. Next one, negative 2x minus 5 multiplied by minus 1 over 9 cosine 3x. Third one, negative 2 multiplied by minus 1 over 27 multiplied by sine 3x plus the constant c. So this can be written as 1/3 x squared minus 5x plus 1 multiplied by sine 3x minus with minus will give me plus, so it is plus 1 over 9 multiplied by 2x minus 5 cosine 3x minus with minus is positive, so this will be plus 2 over 27 sine 3x plus constant c. So this is the integration of the given problem. So we can apply the integration by part many times, or I will call it in this case as tabular method. But just we are repeating the integration by part 1 or 2 or 3 times. So it is just a repeated integration by part, and we give it this name tabular method. And especially if I have polynomial multiplied by exponential or trigonometric function, so it is easy to find the integration for either the exponential or trigonometric functions.